Okay, let's continue where we left off on Module 1, Lesson C. Lesson 3, Student Page C, Page 2. Woo, that's a lot to say. Okay, so let's do one more together, and then you guys can try one. This one tells us to go back 7. So we start at 0 and go back 7. And then it's positive 3, so that means go up 3 from that point. So 1, 2, 3, and we end at negative 4. So that means negative 7 plus 3 equals negative 4. So let's see if it fits with our rules from the last video. When the signs are different, subtract. 7 minus 3 is 4. And keep the sign of the larger negative. Yep, makes sense. Okay, so shut off the video and you do the next one on your own. And then turn it back on and we can check them together. Okay, so for this one, we go back 7. And then we go back 3 more. So that lands us at negative 10. And it makes sense if we had negative 7 in our checking account and we went out and used our debit card and spent $3 more. Yep, we'd be at negative 10. So negative 7 plus negative 3 equals negative 10. And that would be yes. And let's just write the rules again, because the more we write them, the easier it will be to remember. Yes, the rules are the same. It doesn't matter whether we're using chips or the number line. Same, add, different, subtract, always keep the sign of the larger. So that's all you need to know for addition and subtraction. Same, add, different, subtract, always keep the sign of the larger. So exact same rules, and when we turn the page and start on subtraction, we're going to write those rules again. Okay, so let's go to the next page. So I don't use the pictures so much like they do in this. They have this thing called I don't know, sea of zeros or something like that. So I just make every subtraction problem addition problem and do it the exact same way. Why do I do that? Because isn't it easier for you to remember one set of rules? Yes, I think so. So when I learned subtraction of signed numbers, I learned that every time you see a subtraction sign, you add the opposite, and there's your addition problem. So add the opposite means you make the subtraction positive, and then 3 gets its sign changed. It has no sign, so that means it's positive, so we make it negative. So you do 2 sign changes, add the opposite. Or what you'll learn as you go and do more of these, this just means 5 positive chips and 3 negative chips. So since I've been doing this for longer than you've been born, I don't do this anymore. I just think of it like this: 5 positive chips, 3 negative chips. So here's my 5 positive chips. Here's my 3 negative chips, and like I said, I don't do it like they do. So I just continue doing it the same way we did it before. That way you have one set of rules to remember. So much easier. And so then we say, okay, this positive cancels with that negative. This positive cancels with that negative. This positive cancels with that negative. And we have 2 positives left over. So I know that 5 minus 3, which you all already know, is positive 2. So I just continue doing it the same way we did in the last set. And if you learned it add the opposite and you want to do that, fine. If you want to save yourself a step and look at it like this means 5 positive chips and 3 negative chips, because you look at the sign in front of it. So 5 positive chips, 3 negative chips, leaves me with 2 positive chips. And then this one would be just the same. For 5, what is this? Oh, okay, nope, it won't be the same. I thought this one went with that. That's why I said that. So this one, remember how I said the minute you see a double negative, your first step before you do anything is to make it positive. That never changes. I see a double negative, so I immediately make it positive. So what problem I'm really doing is -5 plus 3. So before you do anything, you see a double negative, you make it positive, just a big plus sign. And then I even go an extra step and rewrite it, because sometimes having all that writing there, students get confused and don't realize that what they're really seeing is just this problem. So simplify it, make it look nice for you. If it makes a difference between you getting it right or wrong, it's definitely worth it. So then we need 5 negative chips and 3 positive chips. And we say this and this are gone, this and this are gone, this and this are gone. What do we have left? 2 negative chips. So as I said, I do it exactly like the last packet. Last problems we did. 5 negatives, 3 positives, 3 sets cancel, and we're left with 2 negatives. Does it fit the rules? Absolutely. When the signs are different, subtract, keep the sign of the larger. When the signs are different, subtract, keep the sign of the larger, 5. So just think of this as a +5 and a -3. Signs are different, subtract, keep the sign of the larger, plus. So that way you have one set of rules to memorize, and it works for every addition and subtraction, as long as you remember to make any double negative positives before you do the signs. And every semester I have students that don't listen to that. They take the original problem and try to decide, oh, is this a positive or is this a negative? First, make it double negative. Then make the double negative positive. Then rewrite it. Then make your chips or apply your rules. Do not apply your rules before you make that double negative positive. It will not work. Okay, so double negative positive, absolutely the first thing for every problem. So this little box helps you with some of the language. Probably typically most students would say 5 minus 3, but this could also be 3 subtracted from 5, or 5 subtracted by 3. That one's not written down, but any of those are good. And I don't know that you'll ever have to know these. Like, I don't remember them. I look here to remind me what they are. So the first number is called the minuend. The second number after the subtraction sign is called the subtrahend. And when we have a +5 and a -3, the signs are different. So we subtract and keep the sign of the larger, +2. And then on this one, like we did on the second example, we immediately changed that to a plus. But I guess I should have went over the words first. This would be -5 minus -3, or -3 subtracted from -5. -5 is the minuend, -3 was the subtrahend, and to get the answer, this is really -5 plus 3. Signs are different, so subtract. 5 minus 3 is 2. Keep the sign of the larger. And there's our answer, -2. Okay, and that's subtraction. Exact same rules as addition, except when you see the double negative, change it to positive and rewrite your new problem. Okay, so let's practice that on the next page. I love this section. I think it's such a fun section. And I like that you can round it up and state it as one set of rules, because students do not remember rules. You know, maybe you'll remember them for the test and by the end of the class you won't, or in the next class you won't. So I like it that we can condense the rules and just have one set of rules for addition and subtraction, and then another set for addition and subtraction. Excuse me. Okay, Kim, talk. One set of rules for addition and subtraction, and another set of rules for division and multiplication. Okay, so using the integer chips represent the numbers. So this says subtracting 3 from 8. This is such good practice with your translations, because guess what the next class starts with? Translations. And guess what students are really weak on? Not the ones that come from 0-8, because you guys get good practice, but the students that just drop into there. So 3 from 8 means 8 needs to be listed first. So subtract 3 from 8. Okay. Or finding the difference between 8 and 3 is another way you could say. But usually this, well, actually you see both. Find the difference between 8 and 3, or subtract 3 from 8. So I can see now my first number is 8 positives. I'm going to switch colors and do different colors this time. And remember, no sign means positive, and this subtraction means there's 3 negatives, because whatever's in front of us is a sign that goes with it. No sign means they're positive. Subtraction just means 3's negative. So 8 positives, 3 negatives. And then we go 1 gone, 2 gone, 3 gone, and our answer is 1, 2, 3, 4, 5 positive chips. And we all knew that, right? Have $8, go out and spend 3, now you have 5. But then you can see how it fits in with the rule that we learned in the last lesson, or in the last video. When the signs are different, one's positive, one's negative, subtract, keep the sign of the larger, positive. Let me just see. Yeah, let's do one more and then you guys can do the next one on this page. How about that? So we can practice on our verbiage. So this says find the difference between -7 and -2. So I know that means -7 minus -2. But another way to say it is subtracting -2 from, so subtracting -2 from -7. So it's -7 minus -2. And remember what I said, the minute you see 2 negatives side by side, you immediately make it a positive and rewrite the problem. So the problem I am actually doing is -7 plus 2, because those 2 negatives got turned into a positive. Because 9 times out of 10, students try to represent this one, they get it wrong because all that red and the double negative. But when you rewrite it, you'll never get it wrong. It's now just -7 and a +2. So that means I need 7 negative chips and 2 positive chips. So it's so easy once you do that double negative thing. So put that in your head. That is always first. So now we go 1's gone, 1's gone, 2's gone, 2's gone, and I'm left with 1, 2, 3, 4, 5 negative chips, which means the answer is -5. Does it work with our rules? And remember, don't look at the original problem to decide. Look at your new problem. Does it work with the rules? When the signs are different, subtract. 7 minus 2 is 5. Keep the sign of the larger negative. It most absolutely does work. Okay, next one's yours. So turn off the video and do that one and then check back. Okay. So we're subtracting. So I put my subtraction sign, -5, 2 negatives, so I need that, from -6. Or you could say find the difference between -6 and -5. Order does matter. So the number it's coming from always has to be listed first. When they tell you to find the difference, this has to be first, this has to be second. And difference means subtraction. So the minute I see that double negative, I don't do any chips, I don't do anything until I've made it positive. 2 negatives make a positive, and rewritten the problem. And I don't want you to forget why that's true, because sometimes students will go, well, I know to make 2 negatives positive, but I don't know why. Well, we learned that in the last module, or in the last lesson. This is really the opposite of -5. Well, the opposite of -5 is +5. That's why it becomes positive. So don't lose sight of the why. Just memorizing the rules and doing mindless math will get you nowhere. Understand why, because that meant the opposite of -5, which means +5. So now I can do 6 negative chips and 5 positive chips. I like switching colors. I got tired of the red and yellow. So 6 negative chips, 5 positive. I don't look at the original problem for that. I look at the new problem. That's why you add the opposite first and rewrite the problem before you do the chips. So 6, that one's gone, 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 and it looks like all we have left is 1 negative chip. And so we write -1, and then I always check my work. When the signs are different, a positive and a negative, subtract. 6 minus 5 is 1, but don't forget to keep the sign of the larger negative. Beautiful. Math is beautiful, isn't it? Okay, I hope you did well on that one. So next page, more double negatives. So sometimes I've had students ask me about this. Is this a double negative and this? And the answer is no. Double negative, yes. 2 negatives side by side. These 2 negatives are not side by side. That is not a double negative. You would not make a positive. When you're looking at this one, you should think of, wow, I had -5 in my bank account and I went out and used my debit card and spent 3 more. So that means my account is now at -8. So no double negatives there, but here there is. So the immediate first thing I do here is make it a plus and rewrite it. So this problem is 5 plus 3. Man, I don't even need any chips for that. 5 plus 3 is 8. So that makes it so much easier. And like I said, I do not use this stuff. The C is zeros and the, I don't know, all the stuff they use. To me, it didn't make sense. Like the very first year this came out in our district, I tried to explain it and the students are like, I'm so confused. So I said, well, let's go back to the last lesson. Everybody understood the last lesson, and that let's learn it that way. And I've been teaching it like that ever since. Because this, what are they doing here? I don't know. So yeah, I don't do it that way. So if I were drawing this one, I'd draw 5 positive chips. And then I'd draw 3 more positive chips. Nothing cancels, so I'd have 8 positive chips. Okay, so we won't look at their work on that one. Okay, now this one, remember how I said think of subtraction as meaning it's just 3 negative chips. So this one, there's 5 negative chips. And then there's 3 more negative chips. So that's how I look at that one. This negative says the 5 is negative. This subtraction says the 3 is negative. So 5 negative chips plus 3 negative chips, nothing cancels. So that gives me 8 negative chips. And like I said, I don't look at this too confusing. Just do it like we did before. The only thing way you have to think differently is that subtraction sign means it's a -3. And it really is. When you add the opposite, it turns into -5 plus -3. But instead of doing that extra step, just think of the subtraction as meaning -3. Okay, so let's practice. So like I said, we're not going to do these 2 boxes, but we'll do the others just like we did. Subtracting 8 from 3. That means 3's listed first, and you're subtracting 8 from 3. Or find the difference of 3 and 8. Remember how I said when it says find the difference between 3 and 8? It has to be 3 first, 8 second. You can't switch the order. And then when it says 8 from 3, that means 3 goes in front and you're subtracting 8. So when I go to make my picture, I say, oh, that means this is 3 positives because there's no sign in front of 3, so that means plus. And then 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8, because the subtraction sign means 8 is negative. And then I can go ding, ding, ding. And what does that leave me with? 1, 2, 3, 4, 5. -5. Just as easy as addition. Just as easy. You do have to be careful with the wording though. So whatever number it's coming from must be listed first. So a lot of students have it in their head that the larger number is always first. Not true, not true, not true. 50% of the time, that's it. So when it says from 3, that means 3 goes first. Okay, so let's take a look at the next page. I think we'll be able to get through the next page, and then that'll leave us 2, 4, 5 for the next video. We'll see how far we get. Okay. So how about we do one more and then you guys try too, because you really can't learn until you do it yourself. Anybody will tell you that math is not a spectator sport. Do you think you could have learned how to ride a bike just by watching someone? Or learned how to play basketball just by watching someone? Learned how to be a great dancer just by watching someone? No. And you don't become good at math just by watching me teach you. You have to practice. And that's what a lot of students don't get coming from high school. They're like, oh, I didn't have to practice, you know, I just took notes in class. Won't happen in college. You know, I hate to tell you this because then you guys will know how old I am, but I've been teaching 38 and a half years, and I've never had a student pass that didn't do their homework in my class, ever. No exceptions. It just doesn't happen in college because the college math is harder, it's faster. You don't do the homework, you will not pass the class. Plain and simple. And even in the higher level classes, they have you, they don't count homework. They don't make you turn it in. Well, guess what? Students learn real fast. Whoa, I got to do the homework anyway because I won't pass the test if I don't do the homework. So it doesn't matter if they don't give you points for it. You have to do it. Okay, that's your little mom talk from Kim. So using integer chips represent the difference of -2 and -7. So I keep it in the same order. Difference means subtract. So the difference of -2 and -7 means subtract -2 and -7. And then subtracting -7, so subtracting -7 from -2, I can see it's the exact same thing. So it doesn't matter whether you do difference of these two, you'll get that, or if you say subtracting -7 from -2. But you should know both. So I immediately zoom in on that double negative and I make it positive. I never do a single step until I do that. I don't do the chips. I don't do the answer. I don't decide whether the signs are the same or different until after I've done that step and rewritten the problem. Because now it's just a nice simple one. -2 plus 7. So 2 negative chips, 7 positive chips, and I do 1, 2, 1, 2, and I can see 1, 2, 3, 4, 5. That leaves me 5 positive chips. And we can see that follows our rules. Looking at your new problem, not the original. When the signs are different, which they are, one's negative, one's positive, subtract, keep the sign of the larger. Okay, next two are yours, so go ahead and shut off your video, do number 3 and number 4, and then come back and check them with me. Okay. Okay, we're subtracting 3 from -8, so -8, and we're subtracting 3 from it. So subtract 3 from -8, and this says finding the difference of -8 and 3. So difference means subtract. -8 goes first, 3 goes second. So this means I have 8 negative chips. And this means I have 3 negative chips. So 8 negative chips and 3 negative chips have nothing that cancels. So 8, 9, 10, 11. So I have 11 negative chips because nothing cancels. So I just add them together. And let's see if that makes sense. When the signs are the same, add, keep the sign. And they are the same. That's a -8 and a -3. So just switch your thinking. Don't think of it as subtract 3. Think of it as -3. Or you can add the opposite if that's easier for you. So I hope everybody did well on that one. Okay, use integer chips represent 6 and -2, their difference. So difference means subtract, so I do 6 subtract for difference and then -2. And then I make sure it's the same verbiage as here. Subtract -2 from 6. Yep. So the minute I see that one, I go, ooh, 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 double negative. Make it positive and rewrite. So this is just a simple little problem that doesn't even need chips. It's just 6 plus 2, which is 8. And we can see that it'd be 6 positive chips and 2 positive chips. What comes out to be 8 positive chips, because nothing cancels. Okay, well, we're almost at 30 and we're at the end of the page, so we'll stop here and start on page F in the next video. So see you in a few.